Okay, so let's get started. We're going to be taking a look at how to set up things in basic configuration terms for our model fuel equation mode. So this tutorial, we're going to be going through and running through some of the settings over here, configuration, fuel main, making sure the basics are accounted for. The next tutorial, we're going to be jumping in and taking a look at actually setting up the volumetric efficiency table, learning what values are appropriate in the table, and then how the breakpoint axes can be reconfigured. Also understanding MGP, or manifold gauge pressure here, something a little bit confusing for a lot of people when they get started tuning. So we're going to go through all of that. But this training module, we're going to be focusing on the very basic things found in our basics page. So the very first thing I want to go cover here is our configuration, number of cylinders and the engine type. Now the number of cylinders is obvious. We need to set this correct so the link understands how many cylinders to expect for control for both the coils and injectors. This also plays a role in our actual model fueling equation mode, or model fueling equation, for determining air mass. There's a portion in the equation, volume per cylinder. The volume per cylinder is going to be the engine displacement that we have to enter in here. It's going to be in our fuel main tab. And then the number of cylinders. So it's going to be the displacement divided by number of cylinders, allows it to calculate an estimated air mass in the model mode. So we want to make sure we're entering this correctly for a lot of reasons. So in my case, I'm controlling a Honda K24 engine. The number of cylinders I'm going to enter here as 4. Try that again here, number of cylinders as 4, click enter, there we go. Engine type, we're going to be setting this as 4-stroke. Obviously you have some other choices here depending on the engine you're working with. 4-stroke, rotary, or 2-stroke. I have a 4-stroke engine, so we're going to leave that on 4-stroke. Now, other basic things we have to go into through here is the firing order table. This sets the firing order for the engine you're controlling. The Honda K24 engine, it's an inline 4-cylinder engine. Almost every single inline 4-cylinder engine will have a firing order of 1, 3, 4, 2. So we have our cylinders here, that's the associated firing order. This is important, not necessarily for the model mode when we're setting our fuel equation mode, but for any mode that we're operating in, we need to make sure this is right. When we're telling the link to fire the coil and injectors, it will fire them in the correct firing order here. So it's important that we actually verify that this is correct. So that looks good there. Now, injection mode, we talked about this in the last training module. Lots of different options we have to choose here. Most likely you'll be tuning in sequential operation. That's the most ideal when we're working with our G5 and G4X systems. This assumes you have both a crank trigger and a cam trigger so the link can detect 720 degrees of engine rotation and understand where the engine's position was within the engine cycle. So I'm going to use sequential because the Honda K series engine is sequential already from factory. It has cam and crank inputs for the link. Click OK there. The fuel equation mode, we're going to change this from traditional to model. Now, even if you have plans to do flex fuel tuning, you want to still choose model and not model multi-fuel. Model multi-fuel is specific for a flex fuel based tune. So we're tuning in the model mode. We're adding the ability to tie in a flex fuel sensor and then being able to have link track that flex fuel input, the ethanol content in your fuel system, and allow you to vary the fuel spark, if you're turbocharged, even boost pressure based on the ethanol content. But right now we want to keep things simple again, even if you have plans to add in a flex fuel sensor and do a flex fuel based tune. We'll just set up and tune with model right now. Let's go ahead and select that under OK, and it's going to say, do you want to clear the charge temp approximation table to all 0 axes to default values? Yes, we'll just click yes there. Now the equation load source, this is going to be important to select correctly. 99% of the applications you'll be tuning when you're in the model mode will use the load equation source as load equals map. We have some other options here. When we choose load equals map, this is assuming if we double the load, then we double the need for our fuel injector pulse. So for example, in our main volumetric efficiency table here, if we're going from 0, which is atmospheric pressure, and we're going up to 100, that would mean that we double our actual injector pulse with going from 0 to that 100 MGP reference in the table. This is typically what we want to choose for most every naturally aspirated, supercharged, or turbocharged engines. Let's go back here real quick. Now, we do have other options here. Load equals baro pressure. We only choose this option if you have a set of huge cams that pulls little to no engine vacuum, or you're tuning with individual throttle bodies, where your manifold pressure changes so rapidly with throttle input that it is not a usable parameter for fueling calculations. It's very specific, so this is more oriented to an alpha N style tuning strategy. Again, that's with individual throttle bodies, or you have an extreme size camshaft in your engine that pulls just no engine vacuum, and you can't get a good map pressure reading. We would choose load equals baro. In the load equals baro divided by map crossover, this is another unique situation if you're tuning an engine that's individual throttle body and force induction. This would be, for an example, an RB26 engine. They have factory individual throttle bodies and they're turbocharged. So we'll talk about what this means in another tutorial. Load equals off is something I've never actually worked with or chose with the link. There's really no reason to not have load taken into account with our fueling calculations. So we're gonna use load equals map again for 99.9% of the engines and the configurations you'll ever tune with the link. Load equals map is what we're gonna choose. Let's click OK. Engine capacity. This is very important. We've talked about.
Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.